Okay. Hello. Okay. Yes. Uh, start with another part of the chapter, and yeah, this is a kind of a next chapter. Uh, Introduction to the regression. Yes. Hopefully, I'm audible to you all. Just please confirm me, and then I will start the regression part. Okay, audible. Thanks, Aman. Let us start with the regression. So, in a machine learning, uh, currently we have done the unsupervised part, and we have covered the classification part of supervised learning. And currently we are doing, or we are going to do in this week, that is a regression analysis. So where we can use the regression analysis, that is a advertisement. Yes, basically we are doing or using the regression analysis for the forecasting or the prediction purposes. So these are the main applications of the regression analysis. You just have to remember that. And in next week we will do this part of the machine learning, which includes the reinforcement learning. So you must have to remember that we are doing the regression, which is a part of a supervised learning. And what is a supervised learning? In which we have to give the training samples or labeled data. So to train the algorithm and get some kind of a output on the basis of the trained data. So in a regression analysis, the regression analysis consists of a set of machine learning methods that allow us to predict a continuous outcome variable based on the value of one or multiple predictor variables. Briefly, the goal of regression model is to build a mathematical equation that defines the y as a function of x variables. So here you can see that in this case, this is an example of a regression analysis, and we have take the 2D plot, and these dots which are represented in a sky blue or cyan color, they are representing the data points, and this one is a line of regression what we have made on the basis of the position of data set. So this is a basic definition, and now let us understand the regression model with the help of the house price. So the regression, as we know that, basically used for for the prediction and the forecasting purposes, and we can also use the regression for the forecasting of the weather. And here we are doing the predicting prices of a house given the features of house like size, price, etc. But please note that in this figure we are considering only the price on the basis of the area. Currently we are not looking for the any other features. And yes, definitely it is a part of a supervised classifier. And before understanding, there is a B figure. This one is a B figure. And let us understand the figure A. So in figure A, you can just check it out here. These are some data points are there, which is already stored or labeled data. There we can say that this one is kind of okay, size of house. How we can differentiate it? We can just take it as a yards. And this one, for example, this one is a 50 yards, and this one is a 500 yards. So just I have to write it here, 500 yards, and this one is a 25. So we have trained our algorithm where we have put that the price of 25 yard is around $40,000. So this one 4 that is in multiplication, and these values are multiplication of the $10,000. So the 25-yard, uh, the size of house is equal to the, or the price of that house is equal to the $40,000. So in a 50 yards, yes, there is a cost is around $70,000, and this one is a kind, that is a 7. 7 is there, and 7 to 10, there is a $70,000. And similar, we have trained our algorithm on the basis of, we have just put it here. There is cost, and you can easily guess here, that is around 100. There is 100, and the cost is around 85. There is a $85,000. So similar, we have to train our algorithm on the basis of these data points, and here we have considered 1, 2, 3, 4, 5, 6, and 7. And now the algorithm made the regression line. And how it will made? Yes, it is. I'm designing very roughly, but you have to make it very clear, which is actually passing through. Yes, please. Yeah, this is a regression line which pass through in between all those data points. So this is a regression line, and the black dots are representing the data points with respect to the price and size of the house. So this is a initial in which very limited data is there. Yes, in this case, or in a second figure second, and here you can see that there is a in a middle squared, in which there are a lot of data points are there, and the regression line will be look like that. So which is represented by the this purple color. So this regression line has been designed on the basis of the position of all the data points. So this is a you can say that this one is a uh, type of regression. So now there is another question in our mind. What is the difference between, we have already done the classification, we have already done the clustering. Now, what is the difference between classification and the regression? So let us start with the classification. So in a classification, what we have done, we have just there are two types of our customers are there. You can just please uh, assume this example in which there is a salary is there. There is a basically, yeah, loan pays. Yeah, who have take the loans or who wants to take the loan, and you have to identify that where we can take the risk, or where is a lower risk is there, and where is a high risk is there. And here you can see that there is a separation between these 2 points. This one is a higher risk customers whose salaries as well as the age is less, as compared to the this low risk customers whose age is higher, as well as the salary is higher. So we can just do it very easily by marking the line in between them. So there is nothing like a regression, but it is like a separation between the these 2 points. It is also look like, here you can see that there is another example of a classification, that is example B. In a big example, you can say that we can also mark the line like that. So there is a no any regression is there. So that is a very roughly designing, and here you can see that these are the basically errors, these data points. So it is not possible to include these kind of errors in with the help of these classifications. But yes, we can say that we can do it very easily with some uh, expectations of the uh, of error, and we can do the classification. So here there is another part is a clustering. So in a cluster, there is a which is a part of unsupervised classifier in which we don't need a input data set, and in a clustering that there is a yes, the same example is there, but yes, in a clusters we are actually making the clusters not by marking the line in between the 2 points. So in order to, if I want to make the cluster of this example, so I can do it very easily by, yeah, here you can see that I can do it like that. So this is a one cluster and this one is another cluster is there. So these two I can easily convert into the clusters. So that is a part of unsupervised classification in which the training data is not given, and in another case in which training data is given. So that is a part of a classification. So the next part. So here there is a yeah, regression is there. Yeah, regression is there. In a regression, there are multiple data points are there, and we have to just mark a line. Uh, yes, there is a one more difference between there is a between the classification, clustering, and there is a regression. In a classification and clustering, we are just separating the uh, two different class categories. So here we are not differentiating the class categories. There is only one class is there, and we have to identify the uh, for example, there is a data point is there. There is a and if there are multiple data points are there. We have made the regression, and for example, if my data point is existing there, for example, I have made the new data point which is existing here. We have to estimate the cost. Then we can easily estimate the cost that is existing at this point. But yes, with the help of a regression, this is the actual value that we want to expect from this model. But yes, this model will give the main value on the basis of this regression, and there is a little bit error in the expectations, and this is the actual. So this is a predicted value, and this one is actual value. But yes, definitely the difference is very small in between these two values. So we can do the regression, or we can use the regression for the prediction purposes. So to predict the age, to predict the yes, okay, to predict the age as well as to predict the price kind of things. And there is another that is also concerned with the regression model. Then a regression model basically represents the linear relationship between the dependent and the independent variables, and how we can just make the relationship between these two parameters, that is dependent and independent, via a slope. So this one is a regression, and this is a slope, straight line. Here you can just see that there is a slope, and we will discuss the slope part a little bit later in upcoming slides. And these are black, which are representing the data points that we have already cleared this term. And this the slope slotted, the slope straight line representing the linear relationship that fits the given data best is called as the regression line, and it is also called as the best fit line. So which is actually existing in between all these data points. If I have to, for example, if I have made the regression in this type of a line, so you can just check it out here, or you can just compare visually. It is basically covering this point very effectively, but it is too far from the this point. So we need such kind of regression line that crosses in between these two values. First, there is a first point is there, And the second point, we need to just check it out here, a line which just starts from these 2 points. So rest you have to make the, because you can't change the lines like that in this such kind of a format. But yes, uh, you have to remember these 2 points. There is a first point is there is a last 2 points are there, and the first 2 points is there. Your line must pass from these 2 points. So in between these 2 points. So that's, we can say it as a, there is a back swept line which just pass through the all the data points. So yes, on the basis of number of independent variables, we can say that the regression, linear regression, can be represented as a simple linear regression or a multiple linear regression. And let us do the uh, simple linear regression. And in a simple linear regression, whatever we have just done it here, that is a part of a simple linear regression or a single linear regression. And the form of this, we can represent it as a, like this formula. Oh, okay, once again, I have to check it out. Okay, let us start with the, we can just mark it as a this solid line in this kind of a format, and where the y is a dependent variable and x is the independent variable, and b naught and b1 are the regression coefficients, where in actual the b naught is a intercept or a bias that fixes the offset of the line, and b1 is a slope or weight that specify the factors by which x has an impact on y. So the independent variable has an impact on the independent variables. So this is a very basic equation we are normally used to design this line. So this is a, now there are some different cases that exist in a simple linear regression. Now how the beta value is changing. In case of this, if the beta 1 is less than 0, it indicates that the x has a, where x is a, here you can just check it out here, there is a x is a independent variable, there is a independent variable, and these are the dependent variables. So it indicates that the variable x has a negative impact on a y. The independent variables has a negative impact on the dependent variables. If x is if x will increase, then y will increase, and vice versa. So this is a concept when we get the beta 1 less than 0. If we will get the beta 1 is greater than 0, then it indicates that the independent variables has no impact on the dependent variables. So this is another part you have to remember it. How the if there is a lot, there are one or more questions, MCQ questions, which can be arise from the this point. Then, in case of a simple linear regression, and if the beta is 0, or you can see that in this figure, if the beta 1 is 0, then what is actually saying? Is it saying the variable x has an impact or no impact and whatever? So there are a lot of options are there. Then you have to mark the right. So this kind of a question you can expect in the STs or in an end term examination, and that is definitely a 2-mark question. And if the x changes, then there will be no change in the y. Yes, because the y is always 1. So in this case, the beta 1 is 0, and in this case, the beta, here you can easily check it out. If the beta 1 is less than 0, then it is kind of a negative impact. Then if beta 1 is equal to 0, then it has a no impact. And yes, if the beta 1 is greater than 0, then it has a positive impact on a in dependent variables. So this case you have to remember it. And the another part is there. There is a multiple regression. Yes, if we are considering the multiple variables and we have to check it more than one independent variables, then we can use the multiple linear regressions. And it can be easily represented as a in this format. There is just a beta and the x is increasing. And this one is a here you can the all the parameters have been given there. And just we have to check it out here. What is the visual difference between the simple linear regression and the multiple linear regression? Yeah, we can just check it out here. In a simple linear regression, yeah, we have just a marker line. There is definitely a negative impact. You can see that there is a we have marked a line, and these are data points are there. These are data points are there. We have marked the regression, and there is a difference between the data points. That is a considerable. That is an actual value, and this one is a kind of a predictions or a regression. And in another case, there is no only one line. There are multiple lines are there. So there is a two independent variables. There is a that is also represented in form of the 3D plot. So you can't see the multiple linear regression in a 2D model, and this one is a 3D model. So you can easily visualize in the 3D model. So this is a just a visual appearance between these 2 points, and this is a visual representation of the simple and multiple. So in this case, yes, currently we have done a very basic part of the regression. Hopefully you all are able to understand this point. And if there is any question regarding the what is a regression and what are their types, so currently we have done a very basic part. You just have to remember that. And tomorrow we will do the little bit in detail uh, by adding some more examples. Uh, yes. Now please all, you have to mark your attendance for today. The links have already been shared to you. Now you can mark your attendance for today. And once you have marked your, okay, if you have any question regarding this, then please write it on a chat box, or you can unmute your mic and ask me directly. And if you have don't have any question, then you can just mark your attendance. And okay, in case if you have any question after this lecture, or you can just put it over the Google Classroom, and I will handle your all the queries over there. And till then, you can mark your attendance and please confirm me. Yes, Vishali. Yes, there is a question from Vishali. There is some network issue earlier, so I have marked that in a so today also. What to do now?